Hello, growers. Want to boost your sales, reach new customers, and streamline your sales process, all from your home office? Ready Farmer 1, my book, is your ultimate guide to making it happen. Imagine increasing your farm's revenue without ever spending a Saturday at the farmer's market. The book will show you how to create, design, and market an online farm store. Learn from real farmers sharing real stories about how they move their stores online, freeing up their weekends and increasing their sales. Get my book, Ready Farmer 1, on Amazon and transform your farm business today. I'm trying to think of something like people know in terms of different species. Dogs, right? You have a bulldog, you have a terrier, you have an Australian cattle dog, right? When you start looking at, but there's not 22,000 types of dogs. When you
No.
look at 22,000 different types of mushroom or forming fungi, what why is there so many species? What's different about each one? Why not obviously each one individually, but why are there so many unique 22,000 unique species instead of 200? What is the differentiation for like evolution? Why
Yeah, that's a difficult question to ask. You can ask the same question, why are there 5 million species of insects? Many of them serve the same ecological roles as others do, but you may find them in different habitats. So with the mushrooms, many of them may look alike, may share very similar physiologies, may not be closely related to each other, but serve similar roles in similar sorts of habitats. So they evolved in the area where their ancestors were and adapted to that local environment. And their morphology was selected for efficiency as they proceeded through time and through generations. And they're there serving roles. Now, one could argue that maybe fewer of them could serve the same number of roles, but that isn't what happens. So I'm not sure how I can answer it
Yeah.
really any better than that there are environments, their species change through time as they adapt to their environments. Sometimes accidents happen and wipe out an entire population, and so it's no longer able to leave any offspring, but those that remain fill in that niche, take over those service roles, and change as the environment changes.
Is it estimated that that amount of species is growing?
Well, things are evolving all the time. So saying, the rate of extinction, does that surpass the rate of evolutionary change? If we keep destroying our environment like we're doing, maybe so. But yeah, I mean, evolution continues, evolution proceeds. With climate change in certain areas, the fungi either have to adapt to those areas or move or die. Right. So as long as everything continues, and as long as we have climate change, there's certainly a lot of evolution proceeding. There's no doubt about that. There's extinction being at the same time. So trying to balance the rate of new species, new speciation, and extinction is a difficult question to address.
When you start looking at species differentiation, there's, like you mentioned, some have gills, some
Yeah.
don't.
Yeah.
There's maybe other features that some of the mushrooms have or fruiting bodies have. Can you talk a little bit about like why would one mushroom have gills and another wouldn't?
Well, that has to do with their evolutionary pathway for one. So if you look at the evolution of the mushroom forming fungi in a group that we typically call the agaricales, that's the name of a large group. Or there's other endings depending upon what taxonomic hierarchy you want to put it in. But they all shared a common ancestor, and that common ancestor probably had a spore-bearing surface that was just smooth. So if you think of something like just a thin sheet of mycelium on the surface of a log, just a smooth little layer of crust, that was more than likely the morphology of the simplest form. Now you take that little thin sheet, and if you want to increase the surface area, one way to do it is to elongate part of that sheet into like a stem and just elevate the stem up. and have all that smooth spore-bearing surface all over the surface of that stem. And all of a sudden you have a club fungus, like the genus Clavaria, something like that, or Clavelinopsis. And then you take that club fungus and you flatten the top of it, and all of a sudden you have a flat, almost a trumpet-shaped fungus, like you do through chanterelles and a number of other groups, Gomphis and others. That morphology is evolved independently a number of different times. And then if you want to increase the surface area for spore production, if you just take a flat sheet, you can only produce so many spore producing structures on that flat sheet. But if you then lift that flat sheet into folds, vertical folds, or you lift it into tubes and line the inside of each tube, you've increased the surface area for producing spores tenfold, 100-fold, 1,000-fold. So this changing of morphology from smooth spore-bearing surface to vein-like spore-bearing surface to gills, which are just plates, parallel plates, to tubes or to spines with the surface on the outside of the spines. Tubes has the spore-bearing surface on the inside of the tubes, right? So all you're doing is increasing surface area to produce more spores. And that is often selected for in the evolutionary process. The more offspring you can leave in the environment, the more chances that those offspring will actually survive, germinate, form a mate, and form another type of mycelium that's capable of producing mushrooms. So in many different areas and cases, evolution has proceeded to increase that surface area for spore production. And again, I'm generalizing here because there are certain lineages that have gone the other direction that have lost that ability as well. But I mean that's why you have these different morphologies, is basically the whole idea. The only reason the fungus, the mushroom, is there is to produce spores. Most of its life of these mushroom-forming fungi, as you know, are spent in the mycelium stage. That's those thin threads that are doing the whole business end. That's where the function of most of the mushroom is. And then when the time is right, the environmental conditions are right, or it's under stress, or lack of available nutrients, etc., it may decide to have sex to leave some offspring, and then it produces a mushroom. So that mushroom is just a sexual fruiting body. And then it's optimal if you can produce the most spores you can on that mushroom. And then different species do it different ways. Boletes, they form few very large fruiting bodies with a big, large spore producing area with tens of thousands of tubes inside of which are produced the spores. And it can produce 1 trillion spores or at least billions of spores in a single fruiting body. And then you have other little tiny mushrooms like little mycenas or little marasmias and these other little groups. They produce lots and lots of little mushrooms. And these little mushrooms are able to survive for weeks on end, producing spores periodically over that time every night. So maybe at the end of those weeks, these 150, 200 little tiny mushrooms produce the same number of spores as one big bolete might have produced, which lasts just a few days to less than a week. So all these mushroom-forming fungi have evolved different strategies, but the bottom line is their strategy is to produce some offspring, to produce some spores, and design a way to get rid of those spores so they are optimally dispersed by whatever that the spore dispersing vector is: wind, water, animals, us.
Hey there, want to spend less time pulling weeds? Check out Soil Shield by Modern Grower. It's the pre-cut landscape fabric solution to help you drastically reduce weed pressure. Just roll it out, staple it down, and plant. Then let it do the work for you. Say goodbye to endless weeding and hello to more free time. Plus, it's high quality, durable, and will last for years, saving you time and money in the long run. It's available in a variety of row and hole spacings to accommodate all the crops that vegetable farmers grow. Learn more about Soil Shield landscape fabric at shop.moderngrower.co or using the link below.